Okay, this is section 3-4 in geometry, composition of transformations. After this one, there is symmetry. And then I think that might be it. So we'll have a test after symmetry, okay? So just so you know. Let's take a look at page 249. In music, when you do a composition, it is several songs put together, isn't it? Well, that's what this is. This is a composition of transformations. So we're going to take, out of the 4 transformations, we're going to put several together, okay? And this can happen. And we're going to look at what happens when we do that. The first one that we're going to put together is what we call a glide reflection. Now you could probably guess that this is a translation and then a reflection. Right? I'm not going to rewrite reflection, but what we have is that we take a figure and we move it and then we reflect it. Okay? All right. So, and you might, Josh, you might have to turn it towards the graph. Let's pass out graphs real quick. Can you go get graphs? Would you go get graphs? CJ, would you grab the pens?
You.
All right. So we're going to do a couple of these, and you got to go in the order that they say that you're going to go, that you need to go. Thank you, guys. Okay, let's say that we're going to look at example 1 on page 249. It says triangle JKL has vertices J, which is 6 and -1. I hope I can do this because it looks like you might have to turn it because K is. Let's change K. How many points
10.
do you have?
We have 10 going this way.
Okay, let's change it. Let's do a new one. Let's go 2, a -1, 5, 4. Will that make it?
Yep.
And then L is, let's say, 3, a -3. Okay, let's change it. So, all right. So, and what we want to do is we want to graph it, and then we want to translate it. That's number 1. We want to translate it. Zero, 4, and then we want to reflect it over the, what does it say, y-axis. All right, this is called a glide reflection, okay? So, let's go ahead and get our triangle. J is 2 and -1, so J is right here. Okay. K is 5, 4. And L is 3, -3. Can we change L to be 4 and -3? Just to get a little bit of spacing. Okay? So, here's your triangle. 4 and what? 4 and -3. All right. There it is, correct? All right. So now if we translate, it's called a glide reflection. So unless it specifically tells you, we slide it first. Okay, and we can slide it up, down. I mean, this could be 2, 4. So we could go over 2 up 4. You know what I'm saying? But each one of these points then goes up 4, straight up. So this is 1, 2, 3, 4. Okay? This is 1, 2, 3, 4. And this is 1, 2, 3, 4. Okay? Now, they go ahead and write in the translation so that we have J prime, K prime, and L prime. So in other words, we have a new triangle drawn that shows just the translation. All right, questions about that? Okay, so yep, go
Can I
ahead.
get a different marker? Let's wiped out.
Here, give it to me. Okay. Now we reflect it over the y-axis. We do not reflect the original. Okay? On the test or a quiz, if I have a triangle and I say do this to it, okay, in one question, then I say, okay, do this to it, you go back to the original and do it, right? So if I said in question 1, would you reflect this over the y-axis? And in question 2, would you translate this? That's 2 different questions, right? But a glide reflection is that we do both of them to the same triangle. So we slide it first and then we reflect it. So we're actually reflecting the prime triangle. Do you understand that? So we're going to reflect this triangle over the y-axis, okay? So J is 1, 2, 1, 2. This is J double prime now. K is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is K double prime. And then L is 1, 2, 3, 4. 1, 2, 3, 4. L double prime. And so now I have a new triangle in this quadrant. And this is my answer. This is my final answer. But we need to see both of them in your picture. Okay? So on your worksheet, it says triangle ABC has vertices, these 3 vertices, and then graph it after the indicated glide reflection. Now let's take a look at a couple of these, right? Let's take a look at number 2. Okay, number 2. Is there any questions on this before I go to number 2? Okay, good. All right, number 2. Let's go ahead and graph the triangle. All right, so has vertices. A is 1, 3. Okay. That's A. And B is -2, 1, -1. And C is 3. And now you can do this on your worksheet, correct? Is that right?
Yes, sir.
You don't have to do it on your, yeah. Please use a straight edge when you're making the sides. Otherwise it looks terrible. I've actually had students go to the wrong point because their lines were so crooked, so that's why the straight edge is nice. Okay, so we want to do, and I'm going to try different colors here, see if it matters. And we're going to do a translation along a -1, 1. So we're going to move everything in -1, 1.
Oh, this is number 2.
This is number 2.
Yeah, it was in number 1.
Okay. You're going to use the same triangle every single problem, I think. Yes.
Yeah.
But you're just going to do different things. So a -1, 1, is that right?
Yep.
So A prime is here. -1, 1. B prime is here. A1, 1 here. C prime is here. So we want to go. Okay. So now I'm purple, and purple looks an awful lot like black, doesn't it?
Sort of.
Is that right?
That's what I
Now,
thought.
why do you think I chose this one? Yeah.
So wait.
Reflection is y equals x. Right? What's wrong?
So we just go left down.
No, it's a negative 1, 1, yes. So you go left 1, up 1, left 1, up 1.
Okay, and we draw it in.
Okay. What page, can you help me find the page? Go to the reflection page, I think it was the reflection.
221.
221, thank you. Who was that?
Really?
Greeley, thank you, Greeley. 221, the reflection page, and turn to page 223. On page 223, there's a table, isn't there? And it says, we're going to reflect across that's the x or y axis, right? You got the wrong table. Turn to page 224. See that table there? Reflection of line y equals x, correct? What do we do with the x and the y? We switch them. We switch them, don't we? We switch them.
So it's pretty much a 180?
Yeah. Okay. Would it be a 180?
No.
The 180 switches the signs.
Yeah.
Okay, we're switching the x and the y, right? So we're gonna take a prime and it's 0, 4. So we wanna go
4, 0.
4, 0.
Oh,
So I'm not using a drawing, am I? Do you see what I'm saying? Kyle? I switch them. So if I got an x, y, and I want to reflect over y equals x, okay? Then I just change the x and the y around. Excuse me.
okay.
And y x. Does that make sense?
Yep.
Okay, and I'm going, remember I'm using my primes because it's a glide reflection, Uton. So I'm using my primes. So I have a -3, 0. So I switch those around, I go 0 and -3. Do you understand that?
That doesn't even look like the same triangle.
Uton, do you understand that?
I do.
Alright. And then the third one is C prime, and it's 2, -1. So I'm going to go on -1, 2. And so if I graph that, it's kind of a mess when you use pencil, isn't it? And all of them are pencil?
Yep.
Okay. Then you've done it right.
Oh, I can barely tell which one's it.
Yeah, it's tough to tell, especially when they put it over the origin, because everything is just lambasted right there, right? You know, what's awesome is when they move the triangle far enough that when you reflect it, that you can see it. Now, so we did 2, right? And then students go, well, how do you do number 3?
It's just the opposite.
No, it's the exact
No, it's the
same.
It's the same. X equals Y is the same as Y equals X. They're just throwing it at you to try to confuse it a little bit. Yes, ma'am.
What coordinates do you want us to put on the paper? Is,
Oh, I don't think I want coordinates.
You just know if it's a jumbled mess in the middle, it's right.
I guess so.
Jay.
Yeah, I think Carly, first of all, I think it'd be hard for you to find the coordinates because everything's a ball and mess. Second of all, I'm not gonna check, I'm just gonna look at your picture. Okay, yes, Uton?
And so on number 3, beside our like A prime, B prime, C prime, do we just put like a comma then A double prime because it's the same?
Yes.
Okay.
Well, just like this. See, I put A double prime. The first is a slide, and I have A prime, B prime, C prime, and the second is a reflection from the prime. And that becomes A double prime, B double prime, C double prime.
Yeah, but since it's the same image, we'll just
It is the same image?
or if it's X
Which one?
equals Y.
X equals Y, no, that's the same as Y equals X.
But you're translating along -1, 2.
not negative.
Have a
one.
Snickers.
Oh, okay.
So you first have to move it negative
Yeah.
1, 2. Yeah, yeah,
Okay, you
okay,
said-
thank you guys, because I didn't understand what he was saying. Okay, so can we have a composition of other things? Yes, we can. First of all, you need to understand that if we have, you remember, you might not remember this, but you remember I talked about an isometry the first day? An isometry is when you do a transformation and you end up with the same size triangle. The same size triangle as you had before. So I take Harper and I move him. He is an isometry because he is the same size as the first one. The only one that doesn't have isometry is a dilation. Remember the 4 transmission:
You get big.
slide, turn, reflection, right?
Mhm.
They all have the same isometry, which means they're the same size except for dilation. So if I do any of these compositions, will my figure be the same size as the original? Yes, it's just moved. Okay, you understand. All right, turn to page 250, please. The composition of 2 reflections in parallel lines can be described by a translation vector that is perpendicular to the lines and twice the distance between the 2 lines. Okay, now this is on the test. I remember. I think both of these are. And it's in the form of maybe of a multiple choice question, maybe? I can't remember. All right, so what happens is we take a triangle. All right? And we take 2 parallel lines that we're going to reflect. Here's the first one, and here's the second one. You see that?
Yep.
Okay. We reflect it this time, and it looks like this. Right? So it flips, right? Is everybody with me? Then we reflect it another time, and which one does it look like?
First one.
Yeah, exactly. It's the same exact one, right? It's so basically two reflections over parallel lines produces a translation. In other words, we could just take this and slide it over and it would fit. Do you understand that? So I'm going to write that out. 2 reflections over parallel lines produces a translation. Okay? Now the translation vector is perpendicular to the parallel line. In other words, this line here this is the translation vector. And this distance from here to here is what? What does it say? Twice the distance between the 2 lines. So this distance here to here is twice the distance of this. So if you know how far it is from here to here, say this is 10, then the distance of the 2 triangles is 20. It's twice the distance. Does that make sense to you? Okay. All right. Now, what happens if we don't have parallel lines? What if we have, what's the opposite of parallel lines?
Perpendicular.
No, perpendicular lines are intersecting lines. So, but we don't have to have necessarily perpendicular. They can just be. Take a look at the next page. This is really hard for me to draw. They have some good drawings of it. Page 251. It says, the composition of 2 reflections in the intersecting lines can be described by a rotation. So the composition over 2 intersecting lines is a rotation. All right? You understand that? So they take a little short line there in the box and they flip it. They flip it once and then they flip it over the second line. You see that? It says about the point where the lines intersect and through an angle that is twice the measure of the acute angle or the right angle formed in front of the lines, okay? So let's say we have two intersecting lines, okay, and we take a figure and we flip it here and here. This is the angle that they're talking about. If this is x degrees, then from here to here is 2x degrees, okay? I think is the way I wanna write that. They write it a little differently, and I'm not sure I'm gonna get myself in trouble here, but let's take a look at, the copy in the figure A and describe the single transformation that maps A onto A prime. Take a look at, B on page 251, example 3B. Page 251, example 3B. Okay, so you see that? Is it blue triangle? They call A,
B.
okay? Yeah, we're on B, but you see the blue triangle.
Mhm.
Alright. When they reflect it over the line M, right? And then they reflect it again. Do you see the 60-degree angle that is between the two lines?
Uh-huh.
So when you flip it again, do you see them? Is it a maroon triangle? It became green and then maroon.
Hello?
Oh, yeah.
The angle between triangle A and triangle A prime, the second one, is 120 degrees. It's always twice what the angle is.
Oh, twice the middle.
Twice the middle between the angle between the lines. Okay, so take a look at number 5 on your worksheet. Number 5. Okay. Now you remember those purple Myras? Okay, we're gonna use that to do those. So I'm gonna pass those out, and then the next 10 minutes or so we're gonna do those so that you have those done before you leave. But if you look at that on page 5, it looks like a flag, kind of, doesn't it? Okay. So it says reflect over the X line first and then the Y. You're going to have to extend the Y out because when you reflect over the X, then the Y doesn't. I mean, you can just put the Myra up, that'll do it for you. But do the X first and then the Y. I've had some problems with students that do the Y and then the X. Don't do that. You got to do it in the order they say. But you can tell me what kind of rotation. Now, you can tell me what kind of rotation it's going to be.
120 degrees.
It's
240.
It's twice that.
Oh, yeah.
Yeah, 240. Okay? It's twice that. And so it says, then describe a single transformation that maps F onto F double prime. Well, we would say it is a rotation of 240 degrees. So you did 2 reflections, Kyle. You're going to reflect this over the x-axis. Then you're going to reflect it over the y-axis. You did 2 reflections, and that is a rotation of 240 degrees. Do you understand that?
Yeah.
Okay. Now, 7 is 2 parallel lines. You got that? And then you're going to reflect number 8 over the x and y axis on an actual coordinate. Okay? So they're all going to be rotations, aren't they? No, the parallel lines will be a translation. So this is going to be a translation. Is that right? And this one's going to be a rotation. And these are 2 intersecting lines because the x and y axis intersect. So this one's going to be a rotation. Okay? You got it. Questions? Okay, so we're going to use our Myras on this one, except for this one. You don't have to use a Myra. Why?
Because we got points.
Because you got points. Okay? All right. So let me get those out. I'm going to turn this around.
Whoa.
Yes, would you put your boards away? Okay. Turn around here. And Jaws, can we get a view of you using the Myra real quick? Okay. Would you pass while you're going back there, Carly? Would you grab the Myras? Pass them out, the purple things up there? Do you remember how to do them? Okay. Help her, because there's 2 of you are going to have, well, maybe not, since there's 2 people gone today.
How many people do we have here?
Just grab them all, and I think we use all of them.
Let's keep digging. Little hole.
If I don't have enough, can somebody share? Who doesn't have one? Carly, do you have one? Can you share with Harper?
Perfect, one of those pirates in Star Wars.
Okay. I'm gonna videotape you doing this. So you're gonna reflect it over the x-axis first. Remember to put your,
I don't need one of these. I really.
So what I can use.
don't throw it.
Which side do we use? Pointy side or not?
No, the beveled side.
I've never used this.
This is the beveled side, right here. Right? Oops, I'm
Yeah.
sorry.
Is there a
It's fine.
difference?
Yeah.
There's like a cave in this room.
Yeah, it's what we call a bevel in glass.
Okay.
Am I just supposed to draw it or what?
Yep, just freehand it.
Oh, this is not like a flat.
You should see the reflection on the other side. Are you going over the X or the Y
Why?
first? You go with the X first.
What?
So, like,
It's in alphabetic
You
order.
just said
that
why.
is so tricky.
No.
I never ever said that.
Yeah.
No, I said you go for the white last.
I must have, because you could never be wrong.
Yeah, normally.
Okay, I'm just gonna put the points and then draw it myself.
Some people like it better to do that.
That's perfection right there.
What? That's wacko.
Feels like I'm tripped out.
Now remember, you're gonna rotate the second one. Excuse me, you're gonna reflect the second one.
Oh.
You don't reflect the original. So you reflect it over the x-axis, then you take the reflection and reflect it again over the y-axis.
What?
What?
How do you do that? Like right here?
What's that?
This goes over.
Okay, yeah, then, yep, and you got that right on there and you draw it on this side. So you're gonna set this, you're gonna set this here, and you reflected it over here. Then you're gonna set it here, and you're gonna reflect this one over
Boom,
here.
that's so beautiful.
I did that. Reflected it up.
X first.
I think it should be down lower.
This.
You see it over here?
Well, I see it right.
Yeah, that's right. And then just go like this right here. Reflect the pencil draw.
You see it on there?
My moon is horrible.
Okay. That's what
Yo,
you got. Yeah.
it goes all the way over here. That can't be right.
Yeah, and you see it over there? Yeah.
Dawson, does it show it for you over the x-axis?
Okay,
or the
Jaws, did
y-axis?
you get it all drawn? Would you show your picture when you're done?
Oh, well, I'm still. Just
Did
for
you
the
take-
first one?
Did you take this one? And reflect it here, then this one, or reflect it over this line?
Oh, I have to reflect.
That's why it's
This one goes reflected over that, yeah.
So like
figured it out.
this.
Except you're gonna have to look the other
I
way.
feel like my controller or something's like messed up on my TV.
Is this right?
That's pretty close.
Alright.
But you get it? Alright.
And now I'm just gonna draw like my little
Okay,
flag.
make sure you erase the other one.
I did.
Okay,
Like that.
yeah. So let's show that.
what do you
We'll have to come in and get Myers. Okay, I'm gonna shut this down.
Do we do like F prime and